Hello everyone. I want to start today's lesson just by going over problems 3 and 4. This was from the assignment I gave for you guys to turn in before spring break. You had to do 3, 4, 5, and 9. So I just want to take a look at 3 and 4 right now. Now, again, pay attention to the directions at the very top because it says clearly set up the solution to the problem. Identify what the variable or variables represent. If you don't list that, you're going to lose some points. We have to be very clear. Then solve and check by using Desmos. Unless otherwise specified, round all final answers to the nearest 1,000. All right, so for number 3, it says an open box, no lid, is to be constructed from a square piece of sheet metal that is 20 feet on each side. So what we want to start with is just making a square as best we can here. It says equal size squares are cut from each corner. So you fill in little squares in each corner. These all measure x by x. Now, if you do this, you're good. But to really understand what x is, when we go to fold this up, x turns out to be the height of the box. Because we're getting like little perforated lines here, that these flaps, once we cut out the corners, we get those flaps that we're going to fold up. So now, originally we're looking at 20 by 20. So originally the full length of the side was 20, but now we're taking off 2x from each end, or an x from each end. So we're going to get a 20 minus 2x here. And then this part right here is also 20 minus 2x. So 20 minus 2x is going to be the length, and 20 minus 2x is going to be the width. Now we need to set up a function. So volume is length times width times height. So we're going to say v of x is going to be our length times our width, which happen to be the same thing. So we could just say it's 20 minus 2x squared times the height of the box, which we'll put out in front. This is what you type into Desmos. Now when you do that, we're going to get something that looks like this. We're interested in maximizing volume, so we want this ordered pair that is showing up here. When you do that, you should get the ordered pair 3.333 and then 592.593. Listing the ordered pair is not answering the question. Here's the answer. We would say, and we can answer both parts of the question in one sentence, because it's saying what is the length of the side of the square, or the height of the box, that will make the box have a maximum volume. And what is that largest volume? So we would say the max, not just the volume, but the max volume that's the 592.593. Volume is measured in cubic feet, because that's how it's given to us in this problem, so it's always cubic units, when the height is 3.333 feet. That's exactly how we want to answer this. All right, 4 and 5 are very similar. So setting up number 4, it says a rectangular garden is to be enclosed with a fence. One side of the garden will be a barn and will require no fence. So right here, this would be the side of the barn. So we're going to have a rectangular fence, 3 sides that look like this. Well, so far we've got 100 feet of fence altogether. So if we call this side x and this side x, this third side is not x. These two sides are equal in measure. If we have 100 feet of fence, that means we're going to take away the 2 x's from the 100. So what's left would be 100 minus 2x. Now this is enough to show us what the variable represents. So there's no need to write out in words what x is, but you need to have this labeled just like this. Now we're trying to maximize area. So area is length times width. So area, A of x, is going to equal length times width, or width times length here, x times 100 minus 2x. And you would type this into Desmos. Now this one could be a little time consuming with adjusting, but this will give us a parabola that opens down, so we're trying to find that vertex there, the max. So you should get an ordered pair of 25 and then 1250. So the answer is the max area that would be the 1,250. Again, this is given to us, our fence is in feet. So this would be square feet. Area is always square units. Now this is asking for both dimensions. So when x, which is the width, so we'll say when the dimensions are, x is 25, so we'll say 25 feet by 100 minus 2x becomes 100 minus 2 times 25, that's 50. 100 minus 50, so we get 50 feet. So make sure you're understanding what the question is and make sure you answer all parts of the question. So here it was asking for the dimensions, which is both the length and the width. All right, so let's take a look at the answers to your assignment from yesterday. All right, so for number 2, and I'll just go back through this step by step, so let me just erase what I have up here. All right, we want to find the inverse of g algebraically, so we start by replacing g of x with y, so we get y is equal to negative 2x plus 4. We simply switch x and y, so x is going to equal negative 2y plus 4. And we solve for y, so we're going to subtract a 4. That's going to equal negative 2y. And we'll divide by negative 2. So y is going to equal x minus 4 over negative 2. So then that means the inverse of g of x is going to equal x minus 4 over negative 2. Now since we have to graph this, let's separate this. So this becomes a negative 1/2 x plus 2. And that's what we have graphed off to the side for part B. So here's g in green. We have a negative 2x plus 4, so that means our y-intercept is at 4. We go down 2 over 1, down 2 over 1, and so forth. And then the inverse of g of x is negative 1/2 x plus 2, so here's our y-intercept. We go down 1 over 2, down 1 over 2. Now get used to writing this out. We also want to graph the line y equals x. That's that red dashed line here. But this statement is very important. So f and its inverse are symmetric with respect to, that's what the WRT stands for, with respect to the line y equals x, so they are inverses. Or we can say f and the inverse of f reflect, this might be a little bit easier this way, reflect over the line y equals x, so they are inverses. Either one of those is good. All right, for part C, this is what we did in class yesterday, very similar. So we want g of its inverse. So we're going to take g of negative 1/2 x plus 2, and then g is negative 2 times that expression plus 4. Distribute. I need to see all these steps. Don't just substitute this in here and go straight to x. You need to show that it equals x. So we get a positive x minus 4 plus 4, which gives us x. The other way around, the inverse of g of x becomes negative 1/2. I don't know why I didn't have that written out here. The inverse of negative 2x plus 4. So that becomes negative 1/2 times negative 2x plus 4 plus 2. So we're going to get a positive x minus a 2 plus 2, so we get x. So this is what, when we go through this process, we want to write this statement out. Since, and this would be a g though, since g, up here as well, those are all bg's, since g of the inverse of g of x is equal to the inverse of g of x, which is equal to x, they are inverses of each other. All right, looking at number 3, just as we did yesterday, you just want to put points on the line that's already graphed here, and then switch around the x and y so they start to make points here. And even if it doesn't look symmetric, draw that line y equals x, and then we can see that they would be reflected over this line. And here what I have in red, that is a function. And then for number 6, my points in purple, I'm just putting nice points on the graph of our function. If it helps, write out the ordered pairs, switch around the x's and y's, and then plot those points. So we get this, what I have here in blue. And then this would pass the vertical line test, so it is a function. Even though it looks kind of vertical at the very top and very bottom, it isn't. It is gradually still increasing and going off to the left, and down here decreasing and gradually going off to the right. All right, so I have another packet for you here working on inverse functions. You're to do all of 1 through 19. Now this is going to act as part of your review. Tomorrow and Thursday we will be going over the Unit 5 review. Your test will be Monday. So the first 7 questions are kind of like fill in the blanks based off of what we were doing yesterday. Couple questions as to what you were doing from like numbers 1 and 2 on the second page from yesterday's packet. 10 through 13, actually 10 through 15, or a lot like 3 through 6 from yesterday's packet. And then 16 through 19, just have you algebraically showing that 2 functions are in fact inverses of each other. But please let me know as you're working on this if you have any questions.